Welcome to The Explainer. Today, we're diving into a cornerstone of modern software, something called Object-Oriented Programming, or OOP for short. It's a really powerful idea that totally changed how we write code. So let's jump right in.
So think about it for a second. Our world is full of complicated stuff. Cars, bank accounts, people. But at its core, software only really gets data and logic. So how do we bridge that gap? How can we teach a program to understand a vending machine or a person in a way that actually makes sense?
And the answer, which was pretty revolutionary, is this. We teach software to think in objects. This is the absolute central idea of OOP. We structure our code not as one giant long list of instructions, but as a community of these little self-contained things that know how to talk to each other.
But you can't just have an object appear out of thin air. Before you can have a thing, you need a plan for that thing. You need a blueprint. And in the world of OOP, that blueprint has a special name. It's called a class. A class is basically the master template. It doesn't represent one specific car, but it represents the whole idea of a car. It lays out what any car will have, its properties, like color or speed, and what any car can do, its behaviors, like accelerating or hitting the brakes.
And this is a really key distinction. The class is that abstract blueprint. It just says a car will have a color and an engine. The object, on the other hand, is the real thing. It's that specific red car with a V8 engine that's actually driving down the road. The blueprint is the idea, the object is the reality.
So in code, that blueprint might look a little something like this vehicle class. You can see the properties, we call them instance variables, are defined right inside. Passengers, fuel cap, MPG. Every single vehicle object we create from this plan is going to get its own personal set of these variables to hold its own data.
Okay, so we have the blueprint. How do we actually build something with it? How does that vehicle class on paper become a real, living minivan object inside our program?
Well, the magic happens with a special kind of method called a constructor. Just think of it like the factory's assembly line. Its whole job is to take that class blueprint and build a brand new object, setting up all of its properties with starting values so it's ready to go from the moment it's created.
So, inside a credit card class, the constructor is absolutely essential. The moment a new card object is created, this piece of code runs. It takes in all the details, the customer, the bank, and assigns them to the new object's internal fields. This is how we make sure every single object starts its life in a valid, predictable state.
It's actually pretty cool how a single line of code, something like vehicle minivan equals new vehicle, is really a four-step process. First, we declare a variable to hold our object. Then, that new keyword tells the system to set aside some memory. Then the constructor is called to initialize everything, and finally, our minivan variable gets pointed to that new object in memory.
Okay, so we can create objects. That's great. But how do we stop them from being messed with in ways we don't want? Like, how do we stop someone from just setting a credit card balance to negative $1 million? This brings us to our next big OOP principle.
This principle is called encapsulation, and the best way to think about it is like a car's dashboard. You use the public interface, the steering wheel, the pedals, the radio, to operate it. But the super complex engine mechanics, all that internal data, is hidden away behind a firewall. This protects the internal workings so you can't accidentally break something important while you're just trying to change the radio station.
And the way we get this protection is by using access modifiers. Now, there are a few, but the two most important ones are public, which means anyone can access it, and private, which is the absolute key to encapsulation. Private data can only be accessed by methods that are inside that very same class. It's a lockdown vault.
So in practice, it looks like this. We make the balance field private. Now no outside code can just reach in and change it. Access is only allowed through public methods we choose to provide, like getBalanced or makePayment. This puts the object in total control. The makePayment method can check if the amount is valid before it ever touches that private balance data.
All right, now let's quickly go over a couple of essential keywords. These are the tools that objects use to refer to themselves and to tell the outside world what they're all about.
First up is the this keyword. It's basically a way for an object to refer to itself. It's how it says me. This is really important for getting rid of confusion, especially in constructors. When you have a parameter with the same name as a field, writing this.field makes it perfectly clear that you're talking about the object's own field. It's a small but vital tool.
So here's a funny thing.
What happens when you just try to print an object? Well, by default, you usually get this. Its class name and then some weird cryptic memory address. And let's be honest, that is not very helpful when you're trying to figure out what's going on in your program.
The solution, thankfully, is to override the built-in toString method. By giving our object its own version, we can tell it exactly how to represent itself as a nice, clean string. We can combine its most important properties into something a human can actually read and understand.
And the result is a massive improvement. I mean, look at that. Instead of some cryptic address, you get a clean string telling you exactly what that object is at that moment. This simple change can make hunting down bugs about 1,000 times easier.
So let's do a quick recap of the big takeaways here. Classes are the abstract blueprints. Objects are the real, concrete instances we build from those blueprints. And encapsulation is that vital principle of bundling data and methods together and using access modifiers to protect an object's internal state from the outside world.
And this brings us to one final thought to leave you with. If a class is a blueprint, what happens when you want to create a new blueprint that's based on an old one? I mean, think about it. A truck is a kind of vehicle, right? It has everything a vehicle does, and then some more. Well, that powerful idea is called inheritance, and that's a topic for another explainer.